Welcome to today's session. As we had said that shall be having an engagement on structure and bonding, that is chemistry form 2. Therefore, welcome and let's engage positively. Thank you. Invite a friend to have us on board. Thank you. We have this chapter which is structure and bonding. Structure and bonding. We may have a very long way so that we can review where we have these terms coming from. Therefore, if you remember very well, in Form 1, during the formation of a compound, we said elements are chemically combined. And the moment they are chemically combined, then we have a mutual force of attraction, which is called a chemical bond. So the chemical bond is responsible for this formation of the compound. Therefore, we shall generally look at the major types of bonds in this session, but mainly we shall introduce with the ionic bonds and then look at the structure that are as a result of ionic bonds. Therefore, we may define several things where we have the structure, where we may say that it is the regular pattern of particles in a compound or substance. So these atom particles, they are arranged in a regular manner. Therefore, from that regular pattern, now they bring about the structure. Majorly, we shall be looking at the ionic bonds. So we can start with ionic bond. So this is a type of bond. We still have another type of bond where we have covalent. We have dative stroke coordinate bonds. Like that. But basically, we can start with the ionic bond. When does ionic bond occur? It occurs when there is complete. It occurs when there is complete transfer of electrons. Basically, you can say we have a atom air, it is giving out or losing electrons, and the same electrons can be gained by atom B. So this one gains the electrons. So if A loses 2 electrons, then these 2 electrons will be gained by B. That is why we are saying there is complete transfer. So we have donation and receiving. The donor gives out the electrons, and then the receiver or the recipient atom receives fully the electrons lost. So now we can start giving out some of the examples. For example, and before you go to the examples, you need to note that NP, that majorly it occurs between metals and non-metals. So now we can have examples. The formation of sodium chloride. So we shall say that it is the sodium atom reacting with a chloride like this. Let me remove this so that we can have the sodium chloride like that. In this case, let's keep away the issues of balancing the equation. We set them aside. But now we are focused on the product that is formed. We are concentrating with the product that is being formed. Therefore, you need to draw the structure of sodium and the electron distribution or the electron arrangement. Therefore, that is sodium. Then it has 3 energy levels because it has electronic configuration of 2.8.1. So this is the first energy level. We have the second energy level. Then we have the third energy level. Then now you can give out the distribution. So the first energy level occupies a maximum of 2 electrons. The second one is having a maximum of 8. And the last one is having 1 because it is number 11, so 2.8.1. Then this one is combining with the chlorine atom. So you can say Cl. This one is still having 3 energy levels. So the first one, Let me use a different shading. We have X, sorry, let me use a dot, a dot, a dot. The second one we have three of the, that is 4 pairs, bringing a total of 8. Then the last one is having 7. So if you look at this one clearly, you can see we are having uh, one electron in the outermost energy level here. Then we have another part where it has 7 of them. Therefore, for sodium to acquire the stability, it must lose this electron, and this electron will be received by the chlorine atom, so that now it has 2.8.8. Okay, so now we need to look at the formation of the ions so that we form the sodium chloride compound. So the sodium has lost its entire third energy level. So now I will draw. So now it is having 2 energy levels in this manner. Then because it has lost the electrons, then I can use the shade. I can say this XX. Then we have the 4 pairs XX. And because this is now an ion, then it will be enclosed in a bracket like this. Then we give it the sign that it is a cation. Then the chlorine now will become a chloride, which now it retains its 3 energy levels, but with an increment of 1 electron because it has received the lost electron. So we have the chloride. Allow me redraw it. I may not be accurate in my drawing, but the understanding and how the content is being pumped in is more important. Therefore, let me use this one. So at first, it had this electron, the number of electrons. First pair in the first energy level, 4 pairs in the second energy level. Then we have the last energy level with 7. But now, this one was lost and it was gained by the chloride. Therefore, we need to use a different shades. so that we may be very clear. So now, not like that, but in this format, like that. So now you can clearly see it, and then you close it like this and give it its sign. Therefore, this is sodium ion and this is chloride ion. The moment you combine them, then now you shall get back to the sodium chloride. Then we are having the bond in between. This one now is what we call ionic bond. Why? Because the sodium atom lost one electron and this electron was gained by the chloride. We may proceed now. May show another example. Now I can proceed to have the one for magnesium chloride. So this one was as a result of magnesium reacting with chlorine, a gas. And then we formed magnesium chloride like that. It is well balanced. Magnesium is number 12, so we can draw its structure with 3 energy levels. So the first energy level is having 2, the second one is having 8, and the last one is having 2. Then it is reacting with the chlorine. So if you look at this one, they are 2. And if they are 2, then it means that during balancing, you need to show it how it is happening. Thank you, Michelle, for following. I can see the comments. I can see successful dreamers. We have Malim Brown Ochango. Thank you so much. Thank you for your encouragement. Keep engaged in the forum. Thank you. So now we'll have to include these two somewhere. Then don't forget, I'll show you when and where. So you draw the chlorine atom like this. First energy level, second energy level, then we have the third energy level. Remember, drawing the complete number of energy levels is only involved during the ionic bonds. But when you come to the rest, we can use the outermost energy levels. So Let's distribute the electrons. We have dots, the first pair, second energy level. We have four pairs. And then the last one, because chlorine is number 17, it is having 7 of them. Like that. And then we are supposed to form the magnesium chloride. But now, before we move to the formation of the magnesium chloride, remember magnesium loses two electrons, whereas chlorine can only accept one electron. That's why we said these two you can see here. These two will be used in balancing so that we make the chlorines to be 2 like that, so that they will be able to accept 2 electrons, each receiving 1, 1. So now we place these 2 here because of the balancing like that. Then we'll have formation of a single magnesium ion. It will have lost its last energy level, so it will have 2 energy levels with what we call octet stability. So now I'll award my arrangement in this manner. Then if you get back to this now, because it is an ion that is being formed, then it will be like this. What is the charge? It is +2. But now when you are showing the ion, you start with the number like this. Then how many chlorides will be formed? They are basically 2. So we'll have our 2 here. Then we have our chloride being drawn here. So it is having 3 energy levels. Like this. I may not draw accurately, but what is important is you follow the steps carefully so that you may understand. Now let me change the shade. So I first place the 7 electrons. So the first, the 17 of them, sorry, will be like this. Then the last energy level will be having 7 of them. But now, since we are forming the ion, it has gained 2 electrons. I want us to look at this one carefully. This one loses 2 electrons. Chlorine can only accept 1, meaning that if we are having 2 chlorides here, then each will receive 1, 1. So from this XX, 1 chlorine will pick and it will be like this. Sorry for changing the shade so much, but it is to help you understand. It is to help you understand. It is to help you understand. The charge for chloride is -1. But now, since they are 2, like this, but now since they are 2, now we'll have our 2 there to show that we have 2 chlorides. To show that we have 2 chlorides. Then in between here, then we have our ionic bonds. We have our ionic bonds. Shortly, let me connect the PC to some power backup. So that we can resume and continue smartly. Then we need some power attention. Yes, now we may proceed. I can see Amitron from India. Michelle James, well understood. That is Matiliko Boys. Ambassador speaks. Good work, senior. Thank you so much. Now we can continue. We may not necessarily give all the examples, but let me give the last one on the same. Let's look at the ionic bonds in magnesium oxide. So this is magnesium. This is magnesium reacting with oxygen. And this is a gas, so that you can get magnesium oxide like that. If you look at it, then the equation is not balanced. Therefore, we can only balance by having 2 here and having a 2 here. This means that this one normally loses 2 electrons. But since they are 2, they will lose 4 electrons. Oxygen, a single atom, can gain. A single oxygen atom can gain 2 electrons. But since they are 2 atoms, they will gain 4. So that thing of saying there is complete transfer of electrons is true. The two magnesiums are losing a total of 4 electrons, each contributing 2, 2. Then the oxygen is receiving each 2, and they are 2 in this case. Have a look. So now we'll say magnesium, which is number 12, is having 3 energy levels. Let me give them the green shade. Then plus 2 oxygen. So oxygen like this. It is having 2 energy levels. There's a dots, a pair. Then we have 3 pairs here because it is number 8. So meaning that it is 2.6. Then what are they bringing out to us? Magnesium, ion, like this. It is having 2 energy levels. Then if we give the number of electrons, it will be a pair, then 4 pairs in the remaining outer energy level. And now we award it a 2 plus. Then we have the oxygens, the oxide now that will be formed will receive 2 each. So oxygen is here still with 2 energy levels. So the first one with 2, the second one with 8 because it has received 2. Now let me change the shade. This one will give it 2 negative. Let me change the shade to indicate that we received 2 electrons like this. So these ones, if you have to show, they came there. Now back to the equation. You can see it is 2mg 2o. So we have 2 here and we have a 2 here. You arrive at 4. You arrive at 4. So the 2 magnesiums lost 4 electrons and they were received by the 2 oxides or the oxygen atoms, so that they can form the ion. Now from here, now we can look at now the physical properties. Now let's look at the physical properties. But before we move to the physical properties, let's look at the structures. So, ionic bonds results to a, a structure called giant ionic structure. And now in this case, I will say that they are crystal-like. The substances with ionic bonding, with ionic bonds, are crystal-like. And this crystal-like is just a solid with the particles arranged in a definite pattern. And now we don't have to look at each and every example, but you can look at, let's consider the structure of sodium chloride. So now we can still continue. We are looking at the structure of the sodium chloride. Yes, here is the structure. You can see the black spots and the white spots. You can see from the shading, the way it is. The black ones are of chloride ions. The white ones are of sodium ions. So this one contains so many sodium ions and chloride ions, but they are arranged in a regular manner. Each sodium ion is surrounded by 6 chloride ions. And because we said in a regular manner, they are equidistant from it. In the opposite way, or the vice versa, all the chlorides, or each chloride is surrounded by 6 sodium ions. So this structure keeps on repeating itself. It keeps on repeating itself. And we have other compounds that can have similar cases of these crystal-like structures, giant ionic structures. For example, we have the potassium bromide, we have potassium nitrate, we have sodium iodide, we have calcium nitrate. Now with that, with a view of that structure, I think now we can move to the next part, which is the physical properties. The physical properties. Of giant ionic structures. I'm having a certain summary. So let me open it. I think you can see it from your hands. So now this is a summary where we are having 4 different compounds. We have their properties, and we start with solubility in water. So we are having sodium fluoride, sodium chloride, sodium bromide, sodium iodide. This one is supposed to be sodium iodide. Sodium iodide. So in case somebody will later follow up and start to put down the notes, then you shall write iodide. Then if you look at this, we are having the common metal, which is sodium, and the group 7 members. Solubility in water, you can see across all of them, they are soluble. The melting point and the boiling point is generally high. We have the electrical conductivity in either one in solid states. All of them, they do not conduct electrical currents. But the moment they are in, this is not melt, it's supposed to be molten or in aqueous solution or aqueous form. All of these compounds will be able to conduct electrical currents. Now I can give the summarized work about these charts you can see here and the relevant questions that can be asked. So here we go. So from what we had seen, all these substances are soluble in water. So we can say, number 1, ionic substances dissolve in water. Why? You can be taught to explain. Because they are made up of, they are oppositely charged, oppositely which are attracted by the water, by the polar water molecules. So it can be asked, explain why giant ionic structures or substances, they do dissolve in water. then you need to explain. The first part is all about to mention the charges in the structures, and then what will happen when they meet with water molecules. Property number two, we have seen that generally the melting points and boiling points are high. We need now to stand and explain why. This is because of the strong ionic bonds which require a lot of it to break. Require a lot of it to break. We have number three on issues of electrical conductivity. On issues of electrical conductivity, where we have said that in solid form, they do not conduct electrical currents. But when it comes to molten or aqueous states, they can conduct current. Just a minute, I see something here. So, you can say giant ionic structures do not conduct electrical current in solid state. Why? Because the ions, we are not talking of electrons, ions are fixed ends. Ends cannot conduct. What else can happen? Ionic structures, currents, conduct electrical currents in either molten or aqueous form or solution. Why? They have, or you can say the ions the ions are mobile. Ions are mobile and conducts current. Thank you so much. We may see each other in our next uh, class, the one for YouTube. We're still having ongoing lessons, online lessons via Google Meet. So in case you are interested, you can focus or you can do some inquiries through my number 0757019011. Keep in touch with Ascending Grades. The future is here with us. Thank you. Bye bye.